In this first example, we're going to use the separation of variable technique. The idea is to get the y's on one side, usually the left side is what I like to do, and the x's on the other. The dx and the dy have to be up in the numerator. So here we're next going to integrate both sides, and when we do that, on the left, we're going to get y squared over 2 equals x squared plus c. Now, whenever the y is on top, that's what we're going to be solving for. So let's solve for y. We will multiply both sides by 2. We'll change that to c1. And then we'll take the square root of both sides. And when you take a even root, 2, 4, etc., you have to add the plus minus. So this is your final answer for this integral. In this example, we're going to multiply both sides by dx and divide both sides by 4y. When we do that, we're going to have dy over 4y equals dx. We're going to take the integral of both sides. This 1/4 will come out, leaving the integral of dy over y. That's going to be 1/4 ln absolute value of y. And on the other side, we're going to have x plus c. Let's multiply both sides by 4, and we're going to have ln absolute value of y equals 4x. I'm going to change 4c to c1. There's a e here, so I'm going to do what I call whirly-bird. And up here in the upper left in pink, we're going to have the absolute value of y equals e to the 4x plus c1. This indicates the fact that there's addition here means there used to be multiplication. So that means this used to be e to the c1 times e to the 4x. Because recall, when the bases are the same, we keep the base and we add the exponents. So we just did this in reverse. This e to the c1 is just 2.7 to a constant, which is another constant. So we're going to have the absolute value of y equals c2 e to the 4x. Now, to remove this absolute value, which we can, we have to add a plus minus on the other side. And that is your final answer. Folks, as I went to erase this problem, I realized that this plus or minus c2 can be renamed as a new constant. So down here in white is your final answer for this solution for y. In this next example, we see that we have dx dt equal t minus sine of t over x squared. And folks, as it turns out, it's going to be very difficult to solve for x. Whatever's on top, that's typically what we solve for. Usually we have dy dx, we solve for the y. Here we have dx dt, we normally would be solving for x, but as we'll see, it's going to get too difficult to do that. Okay, so we're going to multiply both sides by dt when we do that, and then we're going to multiply both sides by x squared. When we do both of those maneuvers, we're going to have x squared times dx on this side, and we're going to have t minus sine of t times dt. We're going to integrate both sides. We're going to have x cubed over 3 equals, these are two separate terms, two different integrals if you will, so it's t dt minus integral of sine of t dt. The first one would be t squared over 2. The second one is going to be negative cosine of t plus c. Okay, let's double check this is correct. If we, actually this should be a plus, my mistake. Okay, I always do that. I take the derivative just to make sure that I integrated correctly. So the derivative of cosine t is negative sine t. So in this case, folks, as mentioned, we're not going to be solving for x. We're going to go ahead and solve for c, actually. To do that, we're going to go ahead and multiply by the least common multiple, or what I call a bomb that blows out all the fractions. So we're going to end up with 2x cubed on this side, equals 3t squared plus 6 cos t plus 6c. And we're going to bring everything to this side, and we're going to just rename 6c as just c, and that is your final solution. Next, for this problem, normally we would solve for y. However, this might get a little bit complicated, so we might end up just solving for c. So in this case, we're going to separate the variables. I think the easiest thing is to multiply both sides by y cubed. So on the left, we're going to have y cubed dy, and then we're going to multiply both sides by dx, and we are set up. On the left, we're going to have y to the fourth over 4. Here on the right, we're going to have x cubed, and then we're going to divide by the new and improved exponent. So we added 1, got to 3, and then divided by the new exponent. And then we're going to add a plus c. We're going to multiply by the least common multiple, and the bomb we're going to choose here is going to be 12. When we do that, we're going to have, on the left side, we're going to have 3y to the fourth, and that's going to equal 8x cubed plus 12c. There's a 12 on this side too. And then we're going to change that to just c and bring the 8x cubed to the other side, and that is your final solution. Next, we have dy dx equals e to the negative y times 2x minus 3. So because the dy is on top, we're going to be solving for y if it is reasonable. Okay, so let's multiply both sides by dx and divide by e to the negative y. So we're going to have e to the negative y on the bottom here, and we're going to have 2x minus 3 times dx on the right. Here we're going to bring the negative y up into the numerator, and we're going to go ahead and integrate that, and that's going to get us just e to the y. On the right side, we're going to separate those into two terms and integrate both. It's going to give us x squared minus 3x plus c. Okay, so next we're going to take the natural log of both sides, and when we do that, this will cancel out, and we're going to get y equals the natural log of the opposite side. And there are no absolute values here because we're just taking the natural log of what we see. This is your final answer for this one. Next, we have dz dt, so we're going to be solving for z as in Zulu. So we can cross multiply here, then divide, or we can just go ahead, let's do that. So we're going to have z squared times dt equals t squared plus 1 times dz. So then we're going to divide by dz first on both sides. We're going to get z squared over dz equals t squared plus 1 over dt. But the problem is these should not be in the denominator, so we're just going to flip them, both of them. So we're going to end up with dz over z squared equals dt over t squared plus 1. Okay, so let's bring the z squared up into the numerator. So we're going to have z to the minus t minus 2 dt, and then we're going to have this in the denominator. And this to me looks like we have an inverse trig function. We have 1 in the numerator, we have a u squared plus a squared situation. There's no radical, and that's a plus sign, so that tells us we're going to have inverse tangent. So we're going to set u squared equal to t squared. That means u is going to equal t. Then we're going to set a squared equal to 1, and a is going to equal 1. So on the left side, our final answer is going to be the, let's see, 1 over the a value, that's just 1 over 1, inverse tangent of u over a. So our u is t, and our a is 1, and that is our right side. Now here, to integrate z to the minus 2, we're going to go ahead and add 1. That gives us z to the negative 1, and divide by the new exponent, which is the same as multiplying. Okay, so now we're going to have to solve for z here, if we can. So this is going to give us, let's multiply through by the negative. So we're going to have z to the minus 1 equals negative arctan of t plus c. So this is 1 over z equals negative arctan t plus c. And when you have this situation, folks, you can just do what I call switcheroo. And you're going to end up with 1 over negative arctan of t plus c equals z. And that is your final answer. In this problem, since the dy is on top, we're going to be solving for y. So let's multiply both sides by dx and divide by y. That will yield dy over y equals 3x times dx. We're going to take the derivative of, the integral of both sides. We're going to get natural log of y equals, we're going to add 1 to that exponent and divide by the new exponent. Okay, to solve for y, we're going to use Whirlybird. And that means up here in the upper right, we're going to have the absolute value of y is going to equal e to the 3/2 x squared plus c. This means that there was formerly a multiplication going on, which was this. This e to the c can be replaced by a c. So now we have the absolute value of y equals c times e to the 3/2 x squared. Now to remove that absolute value sign, we could change this to plus or minus c 3/2, that should be times x squared, and then this plus or minus c can be changed to a fresh constant, and this is our final answer. Next, we have dy on the top, so we're going to try to solve for y. Let's cross multiply here. So we're going to have y times dy equals e to the t times dt. We're going to integrate both sides. On the left, we're going to have y squared over 2. On the right, we're just going to have e to the t plus c. Next, we're going to multiply both sides by 2. We have y squared equals 2e to the t plus 2c. And we're going to change that to y squared equals 2e to the t plus c. And then we're going to take the square root of both sides. And when we do that, we're going to add a plus minus. And that is your final answer. In this next section on solving differential equations, we're going to consider these initial values. And we're going to use these initial values to solve for c and come up with a particular solution. Now, it's very important to decipher what this means here on this side of the differential equation. Namely, what does this mean with respect to the initial conditions? So the first thing to recall is we're always going to be solving for what's on top. So in this particular problem, we're going to solve for y. Okay, now, whatever's on top, okay, let's write down the word top. that variable is going to correspond to what's on the opposite side of the equal sign. So just remember, the top variable will correspond to the opposite side of the equal sign. So in this particular example, it's clear that the y is going to equal 0 as an initial condition. Whatever's on the bottom, this variable is going to correspond to what is in the parentheses. So for this particular problem, our initial condition is going to be that x equals 1. So for each of these problems, I recommend that you take this little step. Write down what we're solving for. It's going to be whatever's in the numerator, that's y. The top variable is going to correspond to the opposite side of the equal sign, which is 0. The bottom variable is going to correspond to what is inside the parentheses. Now that we've written down what we're solving for, as well as what the initial conditions are, let's go ahead and solve this in the fashion that we've been doing thus far in this video. So let's multiply both sides by 2. That's going to yield 2 dy on the left, and multiply both sides by dx. Let's now integrate both these sides. We're going to pull out the 2, and we're going to end up with 2y on the left. And on the right, we're going to have x squared over 2 plus c. Okay, this is an excellent time to plug in these initial values to solve for c. You want to do it early. Okay, so we're going to have 2 times y, which is 2 times 0, equals 1 squared over 2 plus c. That's going to yield 0 equaling 1/2 plus c, because 1 to any power is just 1, and we're going to have a c value of -1/2. Let's go ahead now and reconstruct our answer. We're going to have 2y equals x squared over 2 minus 1/2, and then we're going to divide by 2 everywhere, which is the same as multiplying by the reciprocal, namely 1/2. When we multiply the right side by 1/2, we're going to end up with a final solution here in red of y equals x squared over 4 minus 1 over 4, and this is our particular solution with these initial conditions. In our next example, we have dx over dt equals xt with the initial conditions shown here. Okay, first thing we're going to say to ourselves is we're going to be solving for x, because the x variable is in the numerator. Next, whatever is on top is going to correspond to what's on the opposite side of the equal sign. So here, our initial condition has x equals 1, and the t, which is on the bottom, is going to correspond to what is within the parentheses. Folks, you basically ignore whatever that is. You just follow the steps that I showed you, and you will be able to decipher what initial condition applies to which variable. Okay, let's now go ahead and solve this in standard fashion. So we're going to divide by x on both sides, and then we're going to multiply by dt on both sides. So this is going to yield the integral of 1 over x times dx, and the integral of t times dt. On the left, we're going to have the natural log of the absolute value of x, and on the right, we're going to have t squared over 2 plus c. This is a great time to go ahead and substitute. We want to substitute early. So down here in green, we're going to have x equal to 1. Therefore, the natural log of 1 is going to equal t squared. T is 0 plus c. The natural log of 1 is 0. How do we know? Let's just do a quick description as to why that's true. You know that there's a hidden base e when you're doing natural logs. We're going to do what I like to call whirly-bird, which means e to the question mark equals 1. So the question mark has to be 0. Therefore, the natural log of 1 is 0. So 0 equals 0 plus c. The c is going to be 0. So now we're going to be left with this. Okay, and let's go ahead and remove that. So now we still have not solved for x. How do we know we're solving for x? Because it's in the numerator. So what we're going to do is we're going to do whirly bird again. We're going to say e to what's on the opposite side of the equal sign is going to equal the absolute value of x. And this exponent is always going to be positive. So if you always have a positive exponent for e, then e to the x looks like this with a positive exponent. That x value is that value is always going to be with a positive on this left side. So I believe we could just safely say that this is our final answer to this differential equation. In our next problem, we see that dy is in the numerator, therefore we will be solving for y. Next, we notice that we have initial conditions. The top variable, which is the y, is going to match with the opposite side of the equal sign. And that leaves the x variable, the one in the denominator, is going to match with what is in the parentheses. Again, we ignore this. Doesn't even play a role. Okay, let's go ahead now and separate these variables. We're going to be multiplying both sides by dx and dividing both sides by y squared. So we're going to have x times dx and square root of 1 plus x squared. On the left side, we're going to bring the y up into the numerator and change the sign of the exponent. To integrate that, we're going to add 1, which gives us -1, and we're going to divide by the new exponent, which is -1, which is the same thing as multiplying by -1. Over here on the right side, we might be tempted to consider inverse trigonometric functions, but the problem is that that's a plus sign with a radical, and none of the three, tangent, secant, or sine, fit that pattern. And what we're going to do then is use substitution. So we're going to let u equal 1 plus x squared. du is going to equal 2x dx. dx is going to equal du over 2x. We're going to go ahead and rewrite this integral as x over u to the 1/2 in the denominator times du over 2x, and that used to be dx. The x's are going to cancel. We're going to pull out the 1/2, so we're going to have 1/2 the integral of u to the -1/2 du. We're going to do the antiderivative. We're going to add 1 to the exponent, which is 2 over 2. That's going to yield u to the 1/2. And we're going to divide by the new exponent, 1/2, which is the same thing as multiplying by 2. And that's going to result in those two canceling out. Okay, rewriting this, we're going to have -1 over y equals the square root of 1 plus x squared plus c. Let's go ahead now and substitute. We have -1 for y, so if we have -1 over -1, the left side of the equation becomes 1. And then we're going to have the square root of 1 plus 0 is the same thing as the square root of 1 plus c. So that's going to be 1 equals 1 plus c. Therefore, our c is 0. So, folks, this is your most recent equation. So we can eliminate the plus c. And then to solve for y, we can do what I call switcheroo and just switch these. So way up in the right-hand corner in orange, we're going to have -1 over square root of 1 plus x squared equals y. Next, we have the equation dy dx equals sine of x. We're going to be solving for y. And the y value when we plug in is going to be 2 pi, and the x value is going to equal 1. We're going to multiply both sides by dx. We're going to end up integrating dy as well as sine x dx. When we integrate dy, we're going to get y, and on the right hand side we're going to get negative cosine x plus c. We are now going to go ahead and plug in. We're going to have 2 pi equals negative cosine of 1 plus c. Now, let's talk about the cosine of 1. Folks, that is not the cosine here where you're at 1 comma 0. That's the cosine of 0. So 1 means 1 radian. So we know this is 3.14 radians. Here's at 0. So if we break this up into thirds, that would be 1 radian. That would be 2 radians. And this would be 3 radians plus a little bit more to get to 3.14. So what we're looking for is the cosine of this angle right there, which we're calling 1 radian. So it's going to be approximately that distance. Now, if we remember, if we look at pi over 3, which would be 3.14 over 3, which is slightly greater than 1, that is 1/2. So when we put this in the calculator, we're expecting to get a value of about 1/2. And indeed, when we do cosine of 1 with the RAD showing in the iPhone calculator, I still don't know if that means I'm on radians or degrees, but that's what I see in the upper left portion of the calculator, just above the keypad, the parenthesis sign. And when I do that, I get that cosine of 1 is 0.54, which is about what we expected based on this analysis. So 2 pi is about 6.28. So when we bring this on the other side, we get a c value of approximately 6.823. Therefore, our final answer, our final solution for this problem is y equals negative cos x plus 6.823 as our particular solution. Next, we have dx dt equals e to the t plus x. We see that these exponents are being added. That tells us it used to be a multiplication problem, which is fortuitous because that's going to make it easier to simplify. We're going to divide both sides by e to the x, and that's going to give us e to the negative x dx on the left, and we're going to multiply both sides by dt, and that's going to give us e to the t dt on the right. When we integrate, we're going to get negative e to the negative x equals e to the t plus c. Now, because that x is on top, we're solving for x, and it looks like, oh, I forgot to write down the initial conditions, which was x of 0 equals 0. This inside integer is going to be t, because t is in the denominator, so t is going to equal 0. And the one opposite the equal sign is going to apply to the variable in the numerator, which is x, which is also going to be 0. So at this point in time, we're going to plug in x equals 0 and t equals 0. And we're going to have the following. Negative 1 times 1 is negative 1 equals e to the 0, which is 1 plus c. And our final c value is going to be negative 2. Okay, we're going to rewrite this, and then we're going to endeavor to solve for x. We have negative e to the negative x equals e to the positive t minus 2. We're going to multiply through that negative, and we're going to get e to the negative x equals negative e to the t plus 2. We're going to take the natural log of both sides, and that's the natural log of the entire right side. There's an e here. That negative x is going to come out front. ln of e is just 1. So we're going to have negative x equals this, and then we're going to multiply both sides by the negative, and we're going to have x equals negative ln of negative e to the t power plus 2. Next, we are told dy dx equals 4y, y of 0 equals 3 as the initial condition. So here we're going to be solving for y, and we're going to have x equals 0 and y equals 3. We're literally going to ignore that y. Okay, so let's divide both sides by 4y and multiply both sides by dx. That's going to yield dy over 4y equals dx. When we integrate, we're going to pull out a 1/4, and we're going to end up with natural log absolute value of y. And over here, we're going to end up with x plus c. Let's go ahead and plug in x equals 0 and y equals 3. That's going to give us 1/4 ln of absolute value of 3, which is 3, equals c. Okay, so this is our c value. So we're now going to go ahead and excuse me, erase that c here and replace it with 1/4 ln of 3. Now we're going to multiply through by 4 and both sides, and that's going to yield that the ln of the absolute value of y equals 4x plus ln of 3. We're going to go ahead and do whirlybird, and we're going to end up over here in pink that y equals e to the 4x plus ln of 3, everything in the exponent. This we can change to a multiplication problem, which is going to be e ln of 3 times e to the 4x. This is going to evaluate to 3, and our final answer is going to be y equals 3e to the 4x. For the first time in this packet, we are not solved for a rate. So let's go ahead and solve for dy dx and move that over. So that's going to give us dy dx equals 3y minus yx over 2. So therefore, we're going to solve for y, because y is in the numerator. That's going to be our y value when we plug in, and that's going to be the x value inside the parentheses. Okay, so in order to get the variables separated, I always look for a common denominator. So if I can pull out the y, I can divide by the y. So we're going to have dy over dx equals y times 3 minus x over 2. Okay, and I always go back and redistribute to make sure I did that correctly. 3y minus xy over 2. Okay, now I'm going to go ahead and multiply by dx. So I'm going to bring this over here in white. And I'm going to cross out this. Alexa, cancel. I'm going to cross out that dx. And then I'm going to go ahead and divide by y and cross out that y. Okay, so it looks like I have the variables separated. We can go ahead and distribute and have two integrals here. We can have the integral of 3 dx, pull out a 1/2 integral of x dx on the right side. Over here we have straightforward ln absolute value of y. Now we're going to have 3x minus 1/2 times x squared over 2 plus c. ln absolute value of y equals 3x minus x squared over 4 plus c. Okay, now it's time to plug in. We're going to plug in y equals 1. The natural log of 1 is 0. And x equals 0. So that means anything with an x in it is going to be 0. Our c is going to be 0. All right, let's backtrack here and just erase that c. And now we're going to do whirlybird to solve for y. So we're going to have a y equal to e to the 3x minus 1/4 x squared. With this next example, we are moving back to general solutions with no preconditions, no initial conditions. Okay, so we're going to multiply both sides by dx, and then we're going to integrate. So we're going to have the integral of dy is the integral equals integral x to the fifth plus 7 over x times dx. Okay, folks, we're going to recognize that this is two separate fractions, and we're going to take advantage of that. On the left, we're going to have y. On the right, we're going to have x to the fifth over x plus 7 over x. Now, you would get the same result if you did long division. All right, so here we're going to be integrating the x to the fourth, and then we're going to have plus 7 times the integral of 1 over x. So this is going to be y equals x to the fifth over 5, that's that integral, plus 7 ln absolute value of x plus c. Next we have y prime minus 16xy equals 0. Excuse me, we're going to rewrite y prime as dy dx. We're going to move 16xy to the other side. We're going to divide by y, and we're going to multiply by dx. Okay, when we integrate, we're going to natural log of absolute value of y, sorry, that was dx, equals 16, the integral of x dx, which is going to be 16x squared over 2, which is going to be 8x squared plus c. Okay, let me go ahead and erase all this intervening math here and move these closer together, and again we're solving for y. So we're going to do early bird, and we're going to say e absolute value of y equals e to the c times e to the 8x squared. Okay, so initially this was e to the entire right side of the equation, 8x squared plus c, and then we switched to a multiplication problem. In order to eliminate those absolute value signs, in order to remove the absolute value signs, we're going to add a plus minus to the opposite side. And when we do that, we recognize that plus or minus e to the c can be replaced by a generic c. So this, folks, is our final answer. Next, we have dy dx equals 3 plus y to the second power, which means we're going to be solving for y. We're going to multiply both sides by dx and divide by 3y squared, 3 plus y squared. So we're going to have dy over 3 plus y to the second power equals dx. We're going to go ahead and integrate both sides, letting u equal 3 plus y. All right, so that's going to give us du is going to equal dy. So we're going to have the integral of du over u to the second power, and on the other side we're going to have x plus c. Okay, so here we're going to bring that u to the second power up top, so we're going to have u to the negative 2 du. We're going to add 1, that's going to give us negative 1, and we're going to divide by the new exponent, which is the same as multiplying by negative 1. So this is going to give us negative 1 over u equals x plus c. We're going to go ahead now and substitute back in for u, so we're going to have y plus 3 down below. Okay, we're still trying to solve for y. So let's multiply both sides by y plus 3. We're going to bring y plus 3 up here. We're going to take it away from this denominator, and then we're going to divide by x plus c and take it away from this side. Okay, so this is what we have at this point. Negative 1 over x plus c equals y plus 3. And then we're just going to subtract 3 from both sides. So this should give us our final y value, which is negative 1 over x plus c minus 3.